connected to this? I don't see it. Well, it is. As long as we realize that this is 0 over 0, because sine 0 is 0, 1 plus 1 is 2, 2 minus 2 is 0. No, we will not use L'Hopital's rule, not yet, on this. And what do you think we need to do?
Factor the denominator.
Of course. And what is the factor that must be there for sure? Blindly.
X minus 1.
X minus 1. Awesome. Thank you. So this is sine x minus 1, and then we can figure out the second factor. Okay, and this brings me to another comment. So whenever you factor something, it's okay, especially in a test situation. Take 5 seconds. Multiply them out in your mind and see that you get this. Because I don't want to deduct points for algebra. This is not an algebra class, right? But it gives you a totally different answer if you just put a factor form. So for example, if I put here x minus 5, then the whole thing will collapse because this is not the factor form, right? So make sure that it takes 5 seconds. X times x is x squared. Negative 5x minus 1x is negative 6x, which is wrong. Negative 1 times negative 5 is 5. So this is not the correct factor form. Don't just say, oh, I think it's that. In a test situation, take 5 seconds and make sure that you get the correct form. So, of course, it has to be x plus 2. Take a moment. X squared plus 2x minus x, correct. Positive x. Negative 1 times 2, negative 2, correct. Okay. So now, I have the box, or the rectangle, whatever you want to call it. But you can say you don't have the box here, and it has to approach 0. Yes, I do. If I tell you that x approaches 1, I indirectly tell you that x minus 1 approaches 0. It's the same thing. So then I know this limit. What is it?
One.
That's it. And now, can you give me the final answer? We are applying the limit operator. What is the final answer? I covered it because it's 1. So
1 over x plus 2.
that's not the limit.
Oh, sorry.
X approaches 1. We know how to find the limit, right?
1 over 3.
That's it. Done. Great job. Is this okay? Is this okay? I'd like to look at a couple of applications, like, for example, y equals 1 minus secant x over tangent x. We want to find f prime. And I also would like to look at y equals sine theta cosine theta. Again, y prime. So we can continue and look at the chain rule. Okay, ready? Any questions so far? We feel a little bit better about that sine over x, sine x over x. So can anyone tell us what we need to use for this, to differentiate this function?
Quotient rule.
Very good, thank you very much. Can anyone help? I'll help with the denominator. Can anyone tell us the derivative of the top?
Negative tangent x secant x?
Yes, so secant prime is secant tangent. Very good. Times the denominator. Minus, I copy the top, times the denominator prime.
Secant squared x?
Very good. You don't have to do anything else. I'm happy with it, but let's clean it up a little bit. For this one, we're not doing anything else with it, but let's try to clean it up a little bit. So negative secant x tangent squared. Please do not be tempted to do anything here. That will be a tragedy. Okay, minus secant squared x and plus secant cubed over tangent squared. I'm fine with this. It can be further simplified a little bit, I'm pretty sure, because when I factor secant, I get tangent plus secant. So it can be probably further simplified. I'm fine with it. Let's take a look at the other one. Y equals sine theta cosine theta. Let's stop if you have any questions. Anyone, any questions? Any questions?
So when you multiply secants of x,
Yes?
it basically follows the same thing as if you're multiplying exponents.
Yes, because I copy the base and I add the exponents. Secant to power 1 times secant to power 2, the same base, copy the base, add the exponents. It's similar to y times y squared, which is y to the third. Was that the question, or I misunderstood?
Yeah, I was just confirming.
That's okay. Perfect. Okay, so let's continue with this. What rule is applicable here?
Product rule?
Yes. So remember the product rule? You have to write two products, the sum of two products. Sine prime is cosine times cosine, cosine squared, plus.
Minus?
Exactly. I agree with that. This was too far out. So this is sine theta times negative sine theta. I agree. So the final answer is cosine squared theta minus sine squared theta. I don't know if you remember this. You don't have to change it, but this is the same with cosine twice theta. Any questions? Any?
Does that say
Yes?
plus in the middle? Does that say plus sine theta?
Yes. So sine theta times negative sine theta. So the first function prime is cosine times cosine is cosine squared plus I copy sine, I differentiate cosine, then I multiply them and I get the negative sine squared. This is cosine squared minus sine squared, which is cosine twice theta. Any questions? The chain rule. So what is the chain rule? The chain rule deals with a function inside a function. So this is f comp g, right? It's the composite or composite of f and g. So this is basically an outer function of an inner function. Outer, inner. Why is this inner? It's because it's applied to x first. Once I get a number, then I apply f to that number. So this is not any of the operations that are algebraic operations, adding, subtracting, multiplying, dividing functions. This is something totally different. It deals with something like, so this is x, I apply function g to it to get g of x, which is a number, and I continue applying another function to this number to get f of g of x. Okay, now the question is, how do I differentiate something like this? As an example, how do I differentiate, let's say, 4x squared minus 3x to the 10th power? No, I'm not going to take it to the 10th power and then differentiate. How do I differentiate the square root of x to the third minus 24x? This is the square root of a function. How do I differentiate e raised to tangent x minus 3 cosine x? This is not a pure exponential function. The inner function is tangent x minus 3 cosine x. The outer function is e to the x. Now, what is the inner here? This is the inner. What is the outer? The square root of x. What is the inner here? This. What is the outer? X to the 10th power. So all these situations they're part of what is called the chain rule. Okay. So when we evaluate, let's say this function, 4x squared minus 3x to the 10th power, we have to evaluate the inner first. Evaluate inner first. I get a number and then I raise it to the 10th power. But when we differentiate f of g of x prime, we differentiate the outer of the inner times the inner function prime. If we have a third inner, times that function prime. If we have, and so on and so forth. It goes on forever. That's why it's called a chain. So you can say, okay, oh well, it's not going to make any difference if I do this. True. But as a matter of habit or order, if you want, we always differentiate the outer, then we continue with the inner, and the inner, and the innermost, and that's the chain from the outer to the inner. Now, how do I differentiate the power? Exactly what you see here. So if I have 4x squared minus 3x to the 10th power prime, I have to differentiate the outer first. I bring down 10. I subtract 1 from the power. And then I differentiate this function prime, in other words. So how do I do it with x? X to the 4th or x to the 10th will be 10, x to the 9th. Done. Because this will be x prime, which is 1. But now x prime is no longer 1. So bring 10 in front, subtract 1 from the power, and then differentiate. So this part is this, and then differentiate the inner function to get this. So now let's uncover and put it in. 4x squared minus 3x, and then 4x squared minus 3x. But I haven't finished. I have to differentiate this. So the final answer will be 10. You don't have to do it in 2 steps. I'm explaining it. So 4x squared minus 3x to the 9th times, can anyone give us this function prime?
8x minus 3.
That's it. And you don't have to do anything else. This is done. Now, how do I apply this concept to a square root? So to
Do
this,
we make the function to the power 1 over 2?
yes, times the function prime. So I gave an example here. I made it up. Where is my, over there. So the square root of x to the 3rd minus 24x. So on the side, let's write the formula. So when we differentiate the square root of x, we get 1 over 2, the square root of x, and I should write times x prime. I don't, because we know that x prime equals, that's it. But now I have a function. So the square root of the function prime is 1 over 2 the square root of the function times the function prime. So this square root of x cubed minus 24x prime, just follow the steps. 1 over 2 the square root of this times, and you must put parentheses, otherwise will make no sense. It will not be correct. Times what?
3x minus 24.
3x squared minus 24. That's it. You can rearrange it, put it here if you like. It doesn't matter. It's not going to change anything unless you can simplify. X cubed minus 24x. And now I wanted to talk about that. E raised to tangent x minus 3 cosine x. So let's write the formula first. This is such a nice function. But to be exact, I should be writing this. I'm not, because it's 1. But that's the formula we're going to use. E to a function prime is e to that function, but times the function prime. So then when I differentiate this, let me write it here. So e to tangent x minus 3 cosine x. Can anyone give us the derivative of this? Given the formula.
Secant squared theta plus 3 sine theta.
What happened to the first part?
All of them. Sorry.
I'm not saying it's incorrect to start with this. I'm only saying that we cannot forget about this. So I have to write e raised to tangent x minus 3 cosine x times, perfect, secant squared x plus 3 sine x. I agree. But remember, this cannot go away. Now we also have a different notation that I like to show.